Hi folks, it is the year 2024 and I am back for another hamtastic year of the art of engineering. Got back yesterday from a fantastic trip to Tasmania. Stick around right to the end of the video and I'll show you some of the highlights of that trip. We were going to do a full circuit or a large circuit of the Western Arthurs in Tasmania, the remote southwest. A lot went wrong. We had cramps, we had gastro, we had broken peanut butter jars in my pack because I was dumb enough to put glass in there. Lots of newbie mistakes, and we got to the top. We had a great time at the top. It's a beautiful part of the world. I must say, as a first time at a multi-day hike, it's probably not the best one to choose. But was pining to come back to the shack. As always, ham obsessed. Got back and the pole holding up my end-fed half wave had collapsed, and I managed to break the pole while trying to reinstall it because I did it a dumb way. But anyway, repairs have been done. Antenna is back up, and while I was away, this arrived in the mail. I can't actually remember everything that's in here, so what I'm going to do is I'm going to jump over on the test bench, and I do know that there's a bunch of capacitors in here and also toroids. And the capacitors are for the pi filter, the low pass filter in my homebrewed transmitter that I'm building at the moment. And it's eventually going to be a SOTA rig. So what I've done is, in the original prototype, I've used ceramic capacitors. And I've been told, and I understand that they're not the best capacitor to use. And I just want to see if by using a better quality capacitor, we end up with a better result, especially power-wise and efficiency-wise. At the moment, before you put the low pass filter in, it's up around 4 or 5 watts. Once my low pass filter is in play, it goes down to 1.5 watts. Now, it would be my understanding that a lot of that power is harmonics and not making it through to the power meter anymore. Some of that will be perhaps inefficiencies in those capacitors. So it'll be interesting to see if by adding a better quality capacitor, we end up with a higher power output. Keeping in mind, of course, that it's QRP and every milliwatt counts. Please like and subscribe. Oh my God, what an absolute mess the test bench is, but I'm wanting to get back into things, and when I have a spare moment, I shall clean up, I promise. Let's see what I actually ordered, because I can't remember.
Okay, always nicely packed.
So, whole lot of stuff here. I'm not going to show you everything that's in here, but there's a heap of stuff. Yellow and red toroids, NPO type transistors, which are better than the ceramic caps that I was putting in that filter that we're going to presently test. Some electrolytics as well, and Zener audio amplifier, LM386s. I've got a few of those. Some IRF 510s, BD139s, BS170s, and some Zener diodes. I think I've actually ordered the parts I need to build a double sideband 80 meter transceiver, which was in the Sprat handbook. So hopefully that will be an upcoming project. But for today, what we're going to do is we're going to get out the capacitors that we require, and we're going to put them into the low pass filter. We're going to do a before power test and an after power test, and we're going to see if it makes any significant difference. Okay, so this is our setup. This is the 7 meg transmitter that I actually tested on air, and this is our low pass filter. So previous video, if you want to have a look at that, a low pass filter, as you can see here, is using very cheap ceramic capacitors. We've got our dummy load over here and our power meter set on 5 watts, which is the bottom scale, and it's giving me about 1.5 watts. So I'm going to get that and write it down, because my brain, being what it is, will forget. Yes, it is exactly 1.5 watts. So now we'll plug in the trusty soldering iron. Is over here. It's heated up, ready to go. We'll get those capacitors changed out and we'll see what the power is. And here is the bandpass filter and the table here. And this is all information that's on the Sprat, the GQRP Sprat site. I will put a link in the description below. Great for building this type of low pass filter, but they also have information for bandpass filters for receivers, which I'm also going to need. So as this project evolves, I'm going to be making a huge amount of use of all of these fantastic Homebrew resources. So that is the low pass filter that we're using, care of that site I just mentioned. And these are the NPO type capacitors, 680s and 270s, that are going to be replacing the cheap ceramics. And just soldering in the last capacitor. I normally have the fan on. So there you have it, folks. Brand new NPO capacitors. Let's have a look at if it makes any difference whatsoever to the power. Now, the bar we have to beat is 1.5 watts. Power on. The bottom scale is 5 watts. Wow, I'm impressed. It's getting very much closer to 2 watts. Not quite 2 watts, but almost there. So it's half a watt, which doesn't sound like a lot, but when you consider we started at 1.5 watts, that's a significant amount of extra power. I will also put it on the Tiny SA because last time I had to do some adjustments with other capacitors to get the filter to do what I wanted it to do. Part and parcel most likely that my inductors were not quite as accurate as they needed to be. But let's have a look at the Tiny SA. So this is our setup for measuring harmonics. We have an attenuator here, obviously the transmitter. The attenuator is designed to stop large power from getting to your Tiny SA and destroying it essentially. So this is a 10 watt 40 dB attenuator. So it is more than good enough to look after this 2 watts of power coming out of this transmitter. When we hit transmit, you can see there one very small harmonic off to the right, that first harmonic. They're all down, it's 10 dB per division 10, 20, 30. So it's well over 40 dB down on the harmonic. The whole thing is looking a lot cleaner as well. So I would be saying that the quality of the capacitors not only improves your overall power output by a good deal, but it also cleans up the output. Hi folks, haven't posted in a while. Sorry if there's a lot of wind noise. As you can see, I am having an idyllic holiday in the south of Tasmania, and we are having weather that is, I would say, pretty unprecedented. It's almost been like Queensland weather. We're at about 3,500 feet, about 20k hike in, and just really enjoying this place. Busy. It's been busy at night time, but most of the hikers have moved on. We've decided to stay here for a couple of days. Had one of our people ill for a bit of time, and the hike in nearly killed me. That is what's happening, and that's why you haven't seen any videos, but I will be back, and I will be doing lots more videos very, very shortly. And to all the people that have supported the channel in 2023, thank you very much. And to any new people that appear in 2024, also a big 73 from a VK to AOE. Wow, still here. Thank you for sticking around right to the end of the video. Hope you enjoyed sharing my travels with me. I had a fantastic holiday. Just wish I had a rig with me, but unfortunately weight was of extreme concern, so I didn't have anything that was really fit for purpose. But I'm hoping to make sure that the next time I do take a multi-day hike that I will have a nice and compact rig that I can take with me. And I'm going to try and either make it a kit, probably a QRP Labs kit, or preferably Homebrew. It was also nice to find out that the selection of capacitors, the type of capacitor you use in a low-pass filter, definitely has a significant effect on performance of the rig. The next videos are most likely going to be, I don't like to plan these things too stringently, it's a very organic process, but it's probably going to be the receiver section of this rig that I'm building, this SOTA rig. And any 602 mixer is most likely going to be employed, and we'll see where that takes us. 73, and I will see you in the next episode of The Art of Engineering.